Okay. Okay, let's get started. Okay, so guys, sorry, I have to take a look at my cheat sheet. Okay, so hi everyone. Thank you for joining DataCon LA 2022. Welcome to the tutorial session. My name is Belle, your host, and our co-host today is Charlie, who is over there. And please be mindful of our COVID regulations and keep your mask on. Also silence your phone during this session. Don't hesitate to raise your hand if you have any questions. This session is currently streaming via Zoom and will be recorded. It will be available online in a few weeks. Today, we have our guest, Zia, and he will be talking about data science. And Zia has been working in industry as a data scientist for many years. He's an expert for this field. So without further ado, I'll hand this over to the speaker. Thanks for being here, Zia. Welcome.
Thank you, Bill. I appreciate that. Everybody can hear me okay? All right, excellent. So again, as I mentioned, my name is Zia. I've been related to the software or the IT or technology industry for over 20 years. I don't want to go anything over 20 because then it makes me look very old. I don't want to look very old. So my white hair gave it away anyways. But that's my background. I am actually from Canada. I worked most of my life in Canada for a very large telecom company called Bell Canada. And I was a consultant there, worked on their cloud team, their data center team as a specialist. And then in 2006, I moved to the US and I moved to Southern California. A lot of my friends were telling me that if I wanted to pursue data science, I would have stopped a little bit more in Bay Area. That would have been a little bit better choice, but I like the weather there, so I said, okay, let's go to Southern California. So that's a little bit about me. I'll be presenting or running this tutorial today for you guys. And to help me with that, I have Jenna Bowman. She is an instructor at LearningFuze, and LearningFuze is actually sponsoring this event for you guys. So, Jen, do you want to introduce yourself?
Hi guys. Yes, so as you mentioned, I'm the instructor at LearningFuze. I am responsible for teaching the module 1 of our data science course. Most of my experience, especially in undergrad, is in biology and environmental studies. So data science relates to those two fields is what I currently focus on. But in our course, we focus on teaching Python, and that is something that we use for data science. So today, if you guys have any questions or need any help or assistance, if you're going to be following along with us during this tutorial, please just don't hesitate to ask me. And the data set that we're going to be focusing on today is a credit limit data set. So we're going to be trying to use this data set to predict the credit limit that a certain customer will have on their credit card based on other information about their credit history, their spending history, and several other features. So I'm going to turn it back over to Zia, and thank you guys all for attending.
All right, guys. So a little bit about, so before I get started, I just wanted to get a pulse of the room here. So how many people actually work in data science or anything related to machine learning, AI, anything on those lines? Anybody who works in that industry? Okay, very good. Anybody who has some experience with coding? Oh, wow, okay. So I can leave now, you guys can teach me. How many people are familiar with Python? And people who are familiar with Python, have you guys used pandas or any library like that? Okay, so people are familiar with pandas. Okay, excellent. All right. Anybody who has background in math or statistics? Very good. All right. Okay, so in a couple of minutes, we are going to talk about the data set a little bit more. And at that point, Jenna will actually share with you guys the how to get the data set when we start the hands-on exercise. So my plan for today is I'm going to talk a little bit about data science. I would like to give you guys a perspective of data. You hear these buzzwords in the industry about data science, machine learning, artificial intelligence, deep learning, big data. So I'm going to give you a little bit of a perspective of how they relate to each other. And if somebody is talking about something, maybe how you can figure out what they're talking about. So I'll give you a little bit of perspective of that. After that, I will talk about that if you're given a problem, how do you take a data science problem and how do you address that problem? Where do you start? How do you start? And then how do you go forward? So hopefully we have about 2 hours. So hopefully we'll be able to cover some of it. How many people are planning to actually follow along the exercise that we're going to do? Oh, so quite a few. Okay, very good. So if you have any difficult questions, please ask Jenna, and you can ask Bella also. But Jenna and Bella, if you have easy questions, ask me. All right. So that's the whole plan. Difficult questions go there. And I'm going to, we spent about 1.5 hours on that exercise. So I'll show you guys how to do it and how to have a problem, how we are going to approach that problem. And you are welcome to ask questions or stop me whenever you have any, especially when we are doing the hands-on exercise. If you are not able to get some result, please stop us there so that we can help you and you can move to the next step. Otherwise, you'll fall behind, and that makes it a little bit difficult for you to actually focus on what is going on. So questions anytime, and if you get stuck, please do stop us. What comes to mind when you think of data science? What is data science?
Analytics plus coding.
Analytics plus coding. So that's a good approach. Anybody else? Any thoughts on what data science is? Data visualization is another aspect of data science. So he mentioned coding. That gentleman mentioned visualization. So there are different tasks that can be done in data science. So this is a definition from Wikipedia. I just picked Wikipedia because if you search data science definitions, you will get 500 of those. So I just picked data science. And the reason I picked is because I like a couple of words in there. So the first one is that data science is an interdisciplinary field. So what that means to me at least is that it is not just one subject. You do not, like as a data science person, you are actually working with multiple different subjects. You are working with multiple different things. These are different disciplines or different fields that when you look at data science, you have to work on. So you mentioned coding. So if you are working in data science, at some point you will have to code. So understanding how to code is always going to be a plus for you guys. So knowing, and again, coding, I'm not saying just Python. You can actually code and work in data science in any computer language that you like. Even for that matter, it's as straightforward as Excel. But there are some languages that have a little bit more advantage over the other languages. So coding is one piece that you do require when you do data science. The second piece is maths and statistics. So these two fields actually are kind of the basis of a lot of analytical work that we do. Stats and math help us analyze data and also kind of make some kind of future predictions that what is going to happen in the future. And we'll talk a little bit more about that. So math and stats is the other field that is required. So those are two. And then the third one, and it's not in any hierarchy, so that it's not that it's the least important, probably it's one of the most important, is business understanding. So I work in the healthcare industry, and for me, when I joined the healthcare industry, when they showed me the data set, I had no idea what that meant. They had words there that I had never heard, they had abbreviations there, I had no idea. So knowing the industry is an important aspect in data science, because we're going to talk today about financial data, or we look at the financial data set. So when we look at that financial data set, you will see that there are some terms in there that may be some new to you guys, or would be new to me also, because we have not, like, I don't work in financial field, so I have no idea of what they mean. So those are some of the things that are required, and business knowledge or business understanding is one of the most difficult things to gain. Until and unless you work in the industry, it is very difficult to gain that perspective, to gain that advantage. That what does that mean? So to me, these three things put together actually make a data scientist. So if you want to be a data scientist, you do need to have understanding of these fields. And then put together, that package is what the data scientist is. Now, outside of that, they have to be people who can think outside the box. They are able to actually look at data and analyze data. They have to be logical thinkers. They should be able to take a concept and then drive information out of that. So those are all things that are required. But those three basic points that we covered, maths and stats, business knowledge, and coding, those are key for anybody to actually be in that field. So if you are looking to get into this field, which I assume a lot of you, because you are here on a Saturday afternoon, so you are looking to get into that field. So if you're looking to get into that field, please pick these fields and try to gain knowledge of that, so that when you get into analytics and data science, and you have an understanding of how the process works. All right. Oh, okay. So there were a couple of terms earlier I said, like big data and data science and artificial intelligence and machine learning. So anybody who understands those terms, what do they mean? Like, what is big data? So,
Just large amounts of data that require computation.
yeah. Sure. So big data, as she said, is data that will not fit on one computer. You really do need, there are some other characteristics of big data also, but generally speaking, it is, you cannot fit that data on one computer. So that is big data. And then data science we talked about, it's basically the science of getting information from data. So we have raw data and we want to get some information out of that data. We want to analyze it. So that's data science. But what is machine learning? And what is AI? And how are they, and what is deep learning? And how are they kind of related to each other? So you hear these big words, or buzzwords, not big words. So this, I like this diagram because it kind of, at least for me, gives me a little bit of a perspective of how the whole ecosystem works. So you can see that the overarching field is artificial intelligence. And when we talk about artificial intelligence, we include robotics in there. We have a few other kind of fields that are in the artificial intelligence realm, but they do not come under the machine learning realm. So artificial intelligence is the overarching field, and within artificial intelligence, we have machine learning. And in machine learning, we try to make the machine smart enough so that they can actually make some decisions for us. And in machine learning, there is one type of machine learning that is called deep learning. And we hear a lot about deep learning, that it is like it's helped take data science and AI to the next level. Yeah, it is very, very good, but it depends on what type of data you have. Certain type of data works well with deep learning. There's some data that may not work well. And we all know that for deep learning, or whenever we're using deep learning, is basically when you use a technique called neural networks. How many of people are familiar with deep learning? Okay, so there is a technique called neural networks and in machine learning. When we use that specific technique to do machine learning, that is called deep learning. And there is a big hype about deep learning these days, and there's a lot of good work that's being done. So when you have lots of data and big data, lots of data, then deep learning does give you better results than machine learning. So it's one of those fields. And then whatever machine learning or deep learning or whatever process you are doing, data science is kind of on the side where you are actually trying to get information from data. So it's kind of a field of its own where analytics comes inside the data science field. And there is one word there on the screen, which is data analytics, but there are a few different types of analytics. So there's descriptive analytics, there is predictive analytics, there's prescriptive analytics. So there are different types of analytics that we do in data science, but analytics in general come under the umbrella of data science. And then it actually uses machine learning to drive that information. So data science uses machine learning to get information from different data sets. Machine is used by data science to actually drive information from it. Everybody's okay so far? Any questions? Okay. So what we are going to do is I'm going to show you machine learning today. And in machine learning, there are two types of machine learning. One of them is called supervised machine learning, and the other one is called unsupervised machine learning. So in supervised machine learning, what we do is we have a data set. We are going to do supervised machine learning today. And we have a data set, and in that data set, we have historical data. And that historical data we will use to actually make a machine intelligent. And then we will give the machine new data so that it can actually make decisions for us and we don't have to make decisions. So we are going to use one of these techniques, regression from supervised machine learning that we do. And in supervised machine learning, you have historical data, where in the historical data, you know that what the customer or what happened or what was the end result of that transaction. So you can train your machine based on that data that can afterwards make predictions for you. Unsupervised machine learning is basically a technique that allows you to make decisions on the fly. So you might have some historical data, but you are actually trying to put together something, you are trying to group things together. So let's think of an example of unsupervised machine learning. So, for example, if you have a car dealership, and the car dealership has an area of like 20 square miles that they want to advertise their dealership, advertise their cars. Now they can send out a blanket flyer to everybody and say that, okay, we have very nice cars, we have very good price, we will give you 0%, which is not possible now anymore, but we will give you a 0% interest rate, come buy cars from us. But most of that information that when you send out, it's not going to go, it's not going to be good information for people, because as a user, you might be interested in an electric car and not just a car. And you might have some other concerns, or you might have a big family, so you might be looking for an SUV, but you're not looking for a sedan at that time. So companies use machine learning to actually group people together. So can I group people together who are interested in maybe electric cars? can I group people who are interested in bigger cars, people who have a little bit larger family, people who have kids who go for soccer or baseball or ice hockey, and they need to carry a lot of gear. So how can I group those people together? So in this case, you do not have an end result. You do not know what group they belong to beforehand, and you're trying to get the machine to do it for you. So that kind of information, that kind of piece is unsupervised machine learning. You do not have the end result of what which group the person belongs to. Whereas on the other side, when we talk about supervised machine learning, so we're going to talk, actually I'm going to cover that in the next couple of slides. What's the next slide? Okay. So the use case that Jana actually talked about a little bit, I want to actually give you guys a little bit of a perspective of that. And I will come to this slide in 1 minute, guys. This is the goal of the project. I'll come back to that slide in 2 minutes. So the goal of the project is that, for example, you get hired by a credit union. Everybody familiar with what a credit union is? Just like a bank, smaller bank, right? So you get hired by a credit union. And that credit union actually has a Visa card that they give out to people. And you get hired as a data scientist, and they ask you to build a machine learning algorithm that when a user comes to their website or to their office or branch, they want to build a machine learning algorithm that will assign a credit limit to the user. So if this, and this is the task that that was given to you. The data set that I'm going to use today is actually available on this site, Kaggle. How many people are familiar with Kaggle? Yeah, so Kaggle has a lot of great data sets available that we can use to practice machine learning. So this is available on there. If you guys want, I can send you the link. I have taken that data set and I have made a couple of tweaks to that data set. The reason is, first of all, the data set was very large. It was more than 250,000 rows. And I was a little concerned that I was not sure how good the Wi-Fi would be here. So I made it a little bit smaller. And then the data set was actually based was given by I believe an Indian company, Indian bank. So the salaries or the credit limits were in Indian rupees. So I converted that into US dollars so that we can all kind of get an understanding. Otherwise, everybody was getting paid like $5 million, and I was like not very happy that I don't get paid $5 million. So I kind of converted that into US dollars so that we have a perspective of that. But that data set is available on Kaggle. All right, so going back to what we have to do. So the task given to us was that, okay, we want you to build a machine learning algorithm that when a user comes to our website, we can assign them a credit limit. Now, as a bank, you want to give people credit cards because that's how you charge interest and that's how you make money. But you don't want to give credit to people who cannot pay you back. Because if you assign a 50,000 limit to me, maybe you will not get it back. So you have to be very careful as a bank who you give money to. Because one way you're going to hurt your business if you don't give out money as a credit to people, because you will not be able to charge interest. And that's what they make money from. The other place is that if you give too much out, you are going to actually start losing money because people are going to default on you. And you will start losing. So as a banker, you have to be careful about what you are doing. I actually wanted to show you guys what the data set has, but that's okay. So let's think about this problem, and let's see how we are going to approach this problem. So this is what is called a data science approach. So when you start at that bank, when you start at that credit union, how are you going to approach this problem? So what do you think is the first step? So you start at the bank tomorrow or today. You go to your office, your manager gives you this problem. What are you going to do now?
Gather data, either through like APIs or like other sets.
Very good, very good. Can I get your name?
Marcos.
Marcos, excellent Marcos. So Marcos said that you will actually try to gather data. So when you start working for a bank, what's the best place to go get data from? Your own database, excellent. So you actually go and knock at the door of your database admin guy and say, here is a bottle of wine guy. Can I get some data so that I can build a machine learning algorithm? Because the boss has given me this job to actually build a machine learning model. And if you ask him nicely, he will give you data set. So we have done the first step, which is the data. So business goal was what we defined earlier. And then the first step was data collection. So we have done the first step, which is data collection. We got the data from the database and we asked him nicely. He said, here is data for the last 5 years. Go have fun. Now, once you get the data from that person, you actually analyze the data because that's what data scientists do. They actually take the data, they analyze it, they make sure there's not bad data in there. They take care of all the problems in the data, and data has a lot of problems. And when you get a data set that has more problems, that is your day to buy the lottery ticket also. Because your chances of winning are very high there. Data has a lot of problems. So once you have analyzed the data, you prepare the data so that the data can be fed to a machine learning algorithm. When we do the hands-on exercise, you will see how you prepare the data so that it can be fed to a machine learning algorithm. Because a machine learning algorithm is nothing but a math equation. It's a mathematical equation, and when you start to send data to that math equation, you have to actually convert it in a certain way so that the math equation can actually do the equation or do the calculation. Once your data is prepped, you send it to the machine learning model or the model or your math equation, and it actually does its job. And once it does its job, you evaluate the algorithm and you find out how good your algorithm is. So you look at the result, you look at the actual result because you're looking at historic data now, because you got the historic data from your database admin person. So you look at the predictions and you look at the results, the actual true results, and you look at your model's predictions and you compare the two. And when you compare the two, you get the error. You find out how wrong your algorithm is. And then, for example, now let's just take a random guess. Your algorithm is off by 20%, which is still a decent algorithm. You're 80% of the times you're right, but you're 20% of the times wrong. So you are like very happy that, okay, I have built a decent algorithm. It's my first day. I think I will get raised today. So you go back to your supervisor or manager's office and say, I put in a lot of effort. Here is the algorithm. Let's run it. So you run the algorithm, you show him the results, and the result is off by 20%. And he says, look, I know you put in a lot of work, you put in effort, but the company's tolerance is only 10%. We cannot take a 20% hit on loss. We can take 10%. So what do you do now? So yes, you can actually, so the gentleman at the back said, refine the model. So you can look at the model and refine the model for sure, but can you do anything else?
Go through the analysis of the data preparation again.
Go to the analysis and data preparation again, make sure that you have not missed anything. So that's also a good thing. Can we do anything else? Excellent. So let's go back to the database admin guy and see if he can give us some more data. So you go there, you again ask nicely that, okay, you gave me 5 years of data last time and I gave it. Do you have more data? And he may or he may not have more data. If you're lucky, he might say, oh yeah, I have another 5 years. We have a total of 10 years of data. Here it is. So he gives you another 5 years of data. You go through the whole process again that we did earlier. You come back to the model evaluation. Now your model is off by 15%. So you improve the model. It went from 20 to 15%, but it's not still at 10%. So you're not looking to go back to your manager now again because you know that he said 10%. So what do we do now? So we went back, we got some more data, and it helped the model. What can we do now? This is the place where you go outside your organization and try to get data. What kind of financial data can you get outside of your organization? Actually, can you name the most important thing when you look at financial data? What's the most important thing that companies look at?
Credit score.
Credit score. I don't know who said that, but yeah, credit score. And the banks do not have credit score. Who has the credit score? Credit unions. And I believe there are 3 of them. I'm not a financial expert, so if anybody knows, you can correct me, but I believe there are 3 credit unions that actually assign. Oh yeah, Charlie is the financial guy. 3, right? So there are 3 credit unions that. So as a bank, you will go to the credit union and say, this person is looking for a loan, give me his credit score. That is getting data outside of your organization. That we call it as external data. And that's not the only place that you can get data from. So you will generally, when somebody is applying for, so that's credit score is one of them, but you would also ask them for their address. Now, when you ask for their address, you can actually, you know what city they live in. Based on the city, you can actually go to the city's website and find out average income for that city. What kind of professionals live in that city? Does the city have a beach in the name? So you can find different things. How many parks are in their city? Those characteristics would or can help improve your model results. So you go outside your organization, and again, you're starting from data collection phase. So you go outside your organization, you collect data, and you bring that data in. And you go through the whole process again, you get to the model evaluation phase again, and now your model is off by 2%. So your error is like 12% or 13%. You're close, but still not there. And at that point, you actually refine the model. You pick a different model. You're like, okay, yeah, this XGBoost is not working. Can I try neural networks? Maybe I should try some regression algorithm. So you switch the algorithms around, or you fine-tune the parameter. Because if you're trying to gain a 10% jump in your error, just changing the algorithm might not get you there. Because all algorithms are fairly established, they are good algorithms, and they give you decent results. And it's the data that actually really helps you out. So the more data you have, the better data you have, the better result you get. Of course, there's some kind of initial understanding that which algorithm you should pick versus which you shouldn't pick is there. But then tweaking the parameters might get you to that 10% threshold. And then you can go to your manager and say, here it is. We need, this is the algorithm, that's what we have built, and then they can deploy that algorithm. So once you evaluate the algorithm and the algorithm works and it's past that 10% threshold, then is the evaluation of the business goal. So then the company will actually take it and implement it in their application, whatever it's a web application or whatever application they have, they will implement there. And then once it's implemented in that web application, they will see the results. And is it helping the business or not? And then they do a business evaluation. And then once that business evaluation is done, then it goes to production. And it's run by the, and when a new user goes on the website, that's the algorithm that actually gives them the results. So this is the whole process of data science. Now, I hope you guys have kind of, you guys noticed this. I did not talk about any technology in this whole process. Subhash, how are you doing? So, guys, have you met Subhash? He is the man behind this whole show here. So let's give him a good round of applause. Thank you, Subhash. Thank you for organizing that. All right, so what were we talking about?
Subhash.
I was talking about that's true. I was talking about Subhash.
We didn't talk about what you said, no. We didn't discuss technology.
Really, so thank you so much. So I was listening that I more than I was. So I went through this whole process of data science, but I did not talk about any technology. Because it does not matter what technology you use. What matters is that you have the process now. You can do this process, half of it in even Excel. But of course, when you do Excel, you will do a lot of things manually. But technologies like, and that's why I said that I'll come back to this slide in a couple of minutes. These are some of the technologies that are available to you that you can use to actually do data science. Now, when you look at technologies, there are commercial technologies, and then there are, this is my fault. The commercial is not spelled properly. And then there are open platforms. So there are technologies that you have to pay for, and then there are technologies that are open or open source that you can use without paying licenses for that. And the technology that we use is Python. And a lot of companies use that technology. And the reason is because it is a mature technology. There is a lot of good work that has already been put in there. Anybody who has a PhD here? PhDs? Okay. So a lot of times when you do PhDs, you will come up with new algorithms or new work that goes into these open platforms as one way of doing that problem. So a lot of PhD students actually contribute big time in these open platforms because they help you code quicker because you can actually use these technologies that these PhD students have worked on. So that's where the technology actually matters. And we use, and again, when I say we, the company that I work for, Learningfuse, we all use Python for that. And today we are going to use Python to actually do that work. So I'm going to actually ask Jenna here again so that she can actually give you the link so that you can get the data set, download the data set. Everybody has Wi-Fi here? Anybody who doesn't have Wi-Fi? Who wants to follow along?
I don't have Wi-Fi.
So if you actually open up, I think it should give you a guest login to USC. And it doesn't require any.
It doesn't require any password.
Yeah, it doesn't require any credentials. And Jenna is going to actually give you the link to that.
Okay, guys. So the website is www.learningfuse, and you can see how to spell it at the top of the screen here. Learningfuse.com /data-con. See if there might be a.
Hey, Jenna, you want to?
Yes, let me type it in here for you guys.
Well,
Are you guys able to pull it up?
can
What's
you look at the Coca-Cola?
again?
Who has not been able to pull it out? Or no? Learningfuse.com. Yeah. maybe-
Yeah, collab's here. Collab? You want collab or no? Start sharing right now. Right here. Okay, let's click it again. No, it's not here. Let me see if it's not working. I'm going to shut out. It's not working. No, it's okay. I'm going to put it up and then rejoin it. Okay. Sorry, it's okay.
So if you guys go ahead and just put your email in the little bar, it should take you to a download page. And then you will
Yes.
have that data set. Go ahead and open it up and take a look while we get the screen sorted.
Who has been able to get the data set?
Oh,
Oh, okay.
Yeah, yeah.
Everybody's able to get to the site, learningfuse.com/.
oh, wait, okay. Sorry. It's a connection problem. There you go.
Open up another tab.
Yeah, just click plus.
All right, for those people who have the data set, if you can go to Google search and search Google Colab. I spelled it wrong there. Google Colab. If you search Google Colab, the first result that you get is this Google Collaboratory. Please click that link once you get to that. Can you guys see this okay? Too small? I think I was trying to zoom in, but I don't think it allows me to.
I just put the window, and then put zoom second one. It's already zoom.
That's okay. Are you guys able to get to Google Colab? Who does not have the data sets? From people who want to actually do hands-on this. Oh, you didn't get it? All right, so thanks. So when you click on this link, it will open up this new tab for you. So click on this new notebook. So once you get here, click on the new notebook tab, and it will open up another browser window for you with something which is called a notebook. Notebook is what we use to actually do coding in. So we are going to use, how many people are familiar with notebooks, Jupyter notebooks? Oh, very good. Okay, excellent. So once you click on that, you will see something like this. You will see a screen like this, and on this screen, the left box here or the left icon here If you click on that icon, that allows you to upload data to Google Colab. So click on that and upload the data set that we just got. Upload that data set to the Google Cloud. And once you have uploaded the data, please give me a thumbs up so that I know that many people are there.
If you guys go to the bottom little file icon on the left side of your screen, it should just look like a file folder. It's a little folder. There should be an upload button, the very first button on the left that pops up when you press the file folder icon. So this little red icon that's highlighted here, if you press that, and then the very first kind of page icon with the pointing arrow is what you want to click on, and then you can upload your data set from there.
How many people have uploaded the data? Good. Anybody able to upload?
Oh,
So I'm going to give people another minute to make sure that they have uploaded the data set.
It's completely okay. We are going to turn off the lights here. So people from that row, they can see.
So we're going to switch these lights off so that it makes it a little bit easier to see what I'm typing here.
Has everybody been able to upload the file to Colab?
Okay, that's perfect.
Is that better?
Is that better?
Okay, excellent. Thank you. Thank you, Charlie. All right. Can I get started? Yeah. Okay. So what we did was we uploaded the data, and the data is in the Google Colab environment, but it is not in our coding environment. So what we need to do is, first of all, we need to get the data in our coding environment. And for us to get data in the coding environment, we need a library called pandas. So I'm going to import the library pandas. And because this is a Jupyter notebook, so if I want to run a cell, I click on this play button and it runs the cell for me. And once the cell is run, I can add a cell below this. And when you take your cursor a little bit above there, you can see this one. So once you see the one, you see all other are blank, but here it has a one. So when you see a number in there, that means that that cell has been run or has been executed already. So this allows us to import that library pandas that we are going to use to read the data. And for using pandas to read the data is very simple. So we are going to actually call this data set loan, because, or not loan, we can call it credit. And we are going to say that from pandas, read the data. So I'm going to say read underscore CSV. And then I am going to take the path from here. So copy path from the file. Copy path and go back in the parentheses here, put a commas, inverted commas, and then put the file name here. And then run the cell.
You can use single or double quotes.
Yeah, you can do single order. Try one more time if I could zoom this a little bit more. Oh, it does. Oh, there you go. right, hopefully this makes it a little bit easier. And in the next cell, we are going to actually call this variable that we call credit, and we run the cell. And once you run the cell, you will be able to see the data. If you are not at this step, please let me know. For people who are not able to see the data. Okay, excellent. So everybody's got to this step. Now we can see the data, and we have age, experience, married or single, house ownership, car ownership, profession, city, address, that kind of information for everybody. This is the historical data that we got from our database team. So when we went to them the first time around, they gave us some data set. This was the data set. Now, this data set can be given to you in a file like this, or they may give you access to the database and say you can get the data from there directly, or they may give you a file. In our case, they gave us the file, and we are going to use that file to actually work with that data. Now, once you have the data in our coding language, what's the first thing that you want to do? You want to analyze the data, and what will be the first step in analysis? Hypothesis, okay, we'll make a hypothesis, yes. But when you're trying to analyze data, what do you look at the first thing? You need a right, so you need a snapshot of your data. At a high level, you need to figure out what does this data have? Where do I start? How do I start? So in order for you to get a snapshot of your data, pandas has this function called info. So when we call this function on the object that we have, this gives us a snapshot of our data. It tells us that we have, so looking at this, it's telling me that I have 70,000 rows in this data. Range of index means how many rows we have. It tells us we have 12 columns, and each column means a feature or a variable or information. We have that information. So we have 12 columns, and these are the columns. So age, experience, married, house ownership, city, state, current job years, current house years, risk flag, and then US dollar credit limit. And this data type column tells us what type of data it is. Is it a numeric data, or is it an object? Object means that it is alphanumeric, so it has words and it has numbers in there. So this is the first step that generally, when we look at our data, we want a snapshot. This gives us a snapshot of the data. All right. Once we have a snapshot of the data, we want to find out maybe a little bit more, and we can pick, we start from one feature and we can go down that feature. But sometimes we are interested in one specific feature a little bit more than the other features. So we can go chronological order, or we can actually start from any. Generally, I like to start from all the features, but you can pick whichever way you want to go. So there is a feature here which says house ownership. I just want to find out what does that feature have in house ownership. So I am interested in finding out that in this data set, house ownership and house ownership. And I want to find out how many values, how many different values are there in this house ownership. So there is this built-in pandas method called unique, which means number of unique values. Anybody comes from a SQL background? SQL? So how will you find that out in SQL? Distinct. So you can actually do distinct. So the distinct in pandas is unique. And you can do distinct, and this will tell us that there are 3 unique values in house ownership. And it's good to know that there are 3 values, but if you want to find out what the actual values are, you can actually do, instead of doing unique, you can do unique. And unique will tell you that these are the 3 values: rented, owned, no rent, no own. I'm not sure what that means, but that's one of the values. So rented, owned, or not rented and not owned. So maybe it's a mortgage or something. Not sure. But this is again where your knowledge of business comes in handy. Because there could be some values that may not make sense for you, but as a person who has business understanding might be able to understand the difference between them. But these are the 3 different unique values that we have in that data set, or in that field in the data set. Now, we know there are 3 values, we know these 3 values. If you want to go a little bit further and you want to find out how many people out of the 70,000 are renting, how many people own, and how many people no rent, no own. So we are taking one further step in there. So again, pandas comes into our help here. And we do this method called value counts. And value counts tells us that out of the 70,000 data points that we have, 64,406 are renting. Owned is 3,500, and no rent, no own is 1,996. So we got a little bit more information about that feature. And everybody's okay so far? Okay. Let me take one step back here, go back to this piece. Can somebody tell me how many types of data are there? So, data types. How many types are there? Excellent. 2 types. Which types? Integer. Oh, so that's here. But if we look at data, data is a little bit. Excellent. So quantitative and qualitative. 2 types. Quantitative, qualitative. Can you just house ownership? What type of data it is? Qualitative. Can you help me identify a quantitative data here? Age. Excellent. So data that is quantitative is basically numbers. So what I looked at here earlier was a qualitative data. Qualitative data is data that is not numbers. And we can at some point convert them into numbers, but it has a little bit different characteristics than quantitative data. And age was one of the quantitative data for us, and this is one of the qualitative data points for us. So I showed you how to look at a qualitative data point, and you can look at any other qualitative data point in the data set, and you will be able to analyze it a little bit more like this. Let's look at how do we analyze quantitative data. So for quantitative data, there is a built-in function that's called describe. Describe actually gives you information about quantitative data. And it has some good information about quantitative data in here. So you can see that the top row says count.
So that tells you how many data points are there. There's 70,000 data points. Mean gives you the average. Then you have the standard deviation. You have minimum. And then you have this different percentiles. So a 25th percentile, 50th percentile, 75th, and then the maximum. So looking at this describe, can you tell me something about any of these points? Any information that you get from this? This is a really good starting point for us when we're looking at it. That's a good observation. And describe can tell you that also, but this info also kind of alludes to that, because you have 70,000 rows and 70,000 is filled in for everything. So no missing data. So info actually gives you that, but you can actually get it from describe also. But let's see if we can get some more insight in the data using this describe. Excellent. Range of. Very good. Very good. So we can see that the youngest person that we have is 21 years old. The oldest person that we have is 79 years old. So it gives us the range of the data that we have. Youngest person is 21, oldest is 79. And the average age of the people is about 50 years. Yeah. Similarly, if you go to credit limit, minimum credit limit is 0. So there are some people in our data set that have no credit, that we have not given any credit to. And then we can see that the average credit limit is $6,274 and the maximum is $12,530. So it kind of gives us a perspective of the range that we have. And generally speaking, if you're looking at age and you have somebody here which is like 153 years old, you know that your data has some problem. So you do need, so describe actually does give you some insight into what kind of data you have and if you have any problems in the data that you should look at. Any questions? Okay, all right, good stuff. All right, so looking at describe, there is a lot of information on there. It's a good starting point because but these are all numbers. And when you look at numbers for a little bit long time, they all look the same. Everything looks like a 0 and an 8. So it is a good idea to graph, because sometimes graphing can actually help you understand a little bit more about the data. So Python has this library called matplotlib. That library actually helps us graph data. So we're going to import matplotlib.pyplot as PLT. And again, we are just giving it an alias of PLT so that we can use that alias to actually do a graph. So let's pick one of the variables here, which is age, and let's do a, if I wanted to see, so there were some people who had some math and statistics background. If I wanted to see the distribution of the data, what kind of graph will help me understand the distribution of data? Very good. Histogram. So histogram is a graph that you can actually look at if you're trying to understand the distribution of your data. So we're going to build a histogram for the column or feature age. So plt.hist. Yeah, somebody said box plot. Who is that? Excellent. Box plot will also do that. Excellent. And this gives us this is the distribution of data. So we have people starting from, remember when we looked at the describe, the people starting from 21 and going up till about 79, I think was the oldest person, 79. And we have kind of very equal distribution of, somehow it looks like that they have kind of filtered the data. Again, the data is from Kaggle, so it's original data, but I have no idea that how they kind of restricted it. So it looks like that we have some kind of very similar distribution of data in this case. We can look at other features also that are numeric. So we can actually look at the US dollar, the credit limit, the US dollar credit limit. Oh.
Can you get percentile
What
distribution?
do you mean percentile distribution? Like how many like how many in each percentile? So can you can absolutely do that, but there may not be a canned function for that. But can you build your own? Absolutely can build your own. And this actually gives you, again, the distribution of, so there are people who have 0 credit limit, and then there was somebody who had 12,000 some hundred credit limit. So it kind of gives you a range or a distribution, or visually shows you how your data is distributed. All right. Okay. So these are basically your quantitative fields. These are your numeric fields, and we are able to do histograms and plots for that. Let's pick a qualitative field. So there is this field called profession. So I am actually curious to see what kind of professions are there. Profession, and what function do I, or what method do I use to actually see what professions or how many professions are there? We did that earlier. Value counts. Value counts is one of them. Let's do n unique first, just to figure out how many are there, because I don't want to do value counts. So there are 51 professions in the data set. So 70,000 people are kind of belong to these 51 professions. And we can do actually value counts now to get an idea of what is the distribution of those. So these are the number of people in each profession. So you can actually see it starts from physicians, and then goes down the list. Computer operators. And I do believe they have data scientists there too. Oh, there you go. So 1,319 data scientists are in this data set. Now, I don't know if you guys are or not, but I am curious in finding out how much credit limit do the data scientists get. I just want to see that if the Indian people are making more than me, and then if they are, then there will be an opportunity to move to India, right? So how can we do that? So we are analyzing data. We are trying to see if we can figure out what is the average credit limit that the data scientist gets, or for that matter, all of these 51 categories. Any thoughts? Cannot describe it because it's a qualitative data, right? Right now it's qualitative. But you're on the right track. So think a little bit more than this guy. You'll be there. All right, so people who have some SQL background and some statistics background might be able to get this a little bit easier. This is what we are going to do is we are actually first going to group by the data by profession. So the first thing is we want our data set to be broken down into groups of each profession. So we will take the full data set, we will divide it into small groups of each profession. And then when we have a group of one profession, we will take their US dollar credit amount and we will add them together and divide it by the number. And that will give us an average credit limit for each profession. So this is my data set. We can do a group by, and I just want to show you how simple Python is and how much life, how easy it makes our life as a data scientist, a data analyst, because these can functions are very, very powerful. So we do a group by, and we want to group by the profession because that is what we wanted to get some information about. So we actually group by profession. So we create smaller groups within our data. And then once we have those smaller groups, the next step that we have is that we want to take the US dollar credit limit. We want to add that together and then divide it by the number. So we are going to use the US dollar credit limit. And when you sum them up and divide it by the number, what is that called? Average or mean. So statisticians call it mean. So I'm going to try and follow the statisticians here. Sorry, there's a period here, not a comma. All right, what did I do wrong? I do not have the right column name, so because I pretend to be a data scientist, so I'm lazy, so I will go and copy it from here. Paste it back here. And this is how you can actually find out limit for each group. What is the average for that group to act US dollar credit limit average for each group. Does that make sense? Any questions on that? No? Okay. I'm going to try this. So this actually gives you a little bit of an idea of, again, the chart is not very utility.fix size, utility.figure, figure, right? And then size.
Yeah, it's for size.
And the first one is X.
Yeah. We need to increase the PCF.
So at least you can now see, thank you guys. You can now see a little bit better. And then there are different techniques of adjusting that. And you can make it nicer looking, make much nicer looking graphs than these ones. So in this way, you basically analyze your data, and a lot of time is spent on analysis of the data, because you need to make sure that the data that you're going to feed to your model is the right data. Now, once we have done this piece, the next step is, so we have analyzed the data. Now we want to prep the data for the model. So remember, we had different steps and we have kind of done the analysis now. And now we are going to move on to the next phase where we are going to actually prep the data so that we can feed it to a model. So how many of you have actually taken some statistics class and understand what a regression is? Some people, okay, very good. So how many of people are familiar with this formula? Y is equal to mx plus b. Everyone is kind of heard of that formula, right? Can you tell me what does this x stand for? Excellent. What major are you? You go to the back. Very good. So X means independent variables. Independent variables are variables that you will provide your algorithm so that they can give you a result for this Y. And Y is our dependent variable. So in this case, our Y would be US dollar amount. Because we want to find out the credit limit. So credit limit is our Y, is the dependent feature. X would be all features that we provide the algorithm. It could be one feature or it could be 10 features. That doesn't matter. Whatever features we provide are going to be the independent features. Then I have another question for you. So what is this M? Data science major.
The slope.
The slope. So M is the slope of the line. So how these independent features affect this credit limit, that is the slope of the line. And you know that the next question is coming, right? What is it? It's the intercept. So it's the y-intercept where your line actually crosses that. So this is a very simple regression equation that you guys have seen. If you have taken higher level maths and high level statistics, you are familiar with a little bit more complicated, but I like simple. So this is what it is. The important piece here is that X is the independent features that we use in our model, and Y are the dependent features that we want to get out of the model, that we want to get predicted. So when we are prepping for the data, that's the first thing that we have to do is we have to create independent features and we have to create a dependent feature. So let's create independent and dependent features. So I am actually just going to use two independent features and one dependent feature. And the two independent features are age and experience. So I'm going to say here, X, which is the independent features, is equal to, from the data set that we have, let's take age, and the second feature is experience. So we are going to take age and experience from these two features. And our dependent feature is going to be what? Credit limit. I'm not sure who said that, but yes, that is correct. So Y is from the data set. It's called USD. Limit. Oh, yeah, thanks. All right, so what we have done here is we have just created the independent features, which are two, And we can take all of them, but I just wanted to start with two. So we will take two features, age and experience. And then Y is our feature, which is our dependent feature, which is the credit limit. So once we have defined the dependent and the dependent features, we go back to our historical data, the data that we got from our database at Benzene. And we are going to use that data to actually train a machine learning model. So the first thing is we pick a model. So we are going to import model and Python. One of the reasons that Python is very popular in data science is because it has a lot of pre-built algorithms. Pre-built, not pre-trained. So pre-built means that the algorithms have all been coded, but they're not trained, and we can train the algorithms based on our data. So we're going to use those pre-built algorithms. You can write your own, absolutely can. I actually had a student one time, and I gave this exercise that can you write a k-meter stable algorithm, and it was over a weekend. And after the weekend, that guy actually wrote his own algorithm. So I don't want you if you are happy to do it, absolutely do it. But we have pre-trained algorithms that you can actually use, or pre-built algorithms that we can use. So we are not going to write our own. We are going to use, which is a pre-built algorithm. And it comes from this library called sklearn, scikit-learn. That is the machine learning library of Python, scikit-learn. S-C-I-K-I-T, scikit-learn. So from sklearn, we are going to get linear model, and we are going to import linear.
It might be model selection.
Sklearn.
Not model selection.
Sklearn dot. It's the model. Import linear. There you go. Okay, so from sklearn.linear model, we are going to import linear regression. You see, there are so many things that it's hard to remember everything. So if you don't remember everything, it's okay, because that's why God created Google, right? You can ask Google. So you can always ask Google what's going on. Outside of the interview, they want you to know it by heart. So we are going to use linear regression in this case to build our model. Now, this linear regression is actually a pre-built class or a pre-built algorithm that we are going to train. So once you have this algorithm here, you can actually name this algorithm whatever you want to name it. You can say LR, which is linear regression, and then you can actually define or instantiate a class of this linear regression model. And in this way, you actually instantiate a class of this, an instance of this class, linear regression, and that is defined in this LR variable or stored in this LR object. The next step is we will take the data that we have, and we will provide it to this model so that it can train. And how we provide the data is, let's look at the data. So we defined independent variables, which were X. So let's look at the X, and we can see that the first row is age is 22, experience is 15. Now, this is X, which is the independent features, and then Y is dependent. So what we are going to tell the algorithm is that when the age is 22 and the experience is 15, that's a lot of experience for 22-year-old. I was like, did I say it right? Or how come so? He started working when he was 7. That's pretty impressive. Asians. Yeah, they work hard. Absolutely. So age 20 to 15 years of experience, you get a credit limit of $4,680. So this is how we are going to actually train our algorithm. Again, it is how good your data is, guys. So if you feed your algorithm good data, you get good results. If you feed your algorithm not so good data or bad data, you're going to get bad results. So it's all about the data that you feed. But how the algorithm trains is that it looks at the first person's age and experience, and then looks at the credit limit and says that, okay, if I get somebody who's 22 years old with 15 years of experience, I'm going to give him a credit limit of $4,600 or $4,680. And then go to the second row, third row, fourth row, and it will learn like that.
So do people usually delete bad data before they proceed further?
Absolutely. So that is one of the pieces in data preparation is that you do need to have good data. Because that principle of garbage in, garbage out.
Right. I mean, 22, 15, probably.
7 years, yeah, that is.
What if it's 22, 37?
Yeah,
Impossible.
that's impossible. So that is bad data.
Right.
And this also is like 7 years is too young to be working. So you might want to look at that kind of. So that all that process is actually in data analysis and data. And you don't have to do that process because there's no shortcut. And the more you do it, the better comfortable you get with the data, and then you can quickly figure out stuff that's not required. Any other questions? All right. So now we are going to give this data to the algorithm row by row so that the algorithm can learn. All right. So our model that we have, the pre-built model is saved in this object LR. So I'm going to use this LR object. And I'm going to say train. So train in Python is actually called fit. And fit is what is the method that is used for training the algorithm. And we will provide the two features that we have, which is X and Y. X is the independent, Y is the dependent. And again, it goes row by row in the algorithm for it to learn. And then once we have fed this information in here, we will run this. And you see it trains in a second because it's a small data set and doesn't go too complicated in there. It trains very quickly. And when it trains very quickly, this is a model that has been trained on your data. So we had a pre-built model. Now we have a trained model. And once we have the trained model, we are going to actually we can actually use this model now to make prediction for somebody else. So for example, if somebody else comes to us and the person is 22 years of age and has 15 years of data, 15 years of experience, we can actually do predict and we can pass. So the age of the person was 22 and the experience was 15, right? The first person that we had. So the first feature here is the age of the person, 22. And the second thing here is the experience of the person, 15. So let's see what the algorithm says when we say predict on this. So the algorithm is actually saying $6,329. So this is the predicted average or predicted credit limit that the algorithm says you can use for this person or you can give this person. So you can see that training the algorithm and making predictions from the algorithm, if you use a pre-built algorithm, doesn't take a lot of effort. All of the effort is before that. And if you ask a data science or an AI person, machine learning person, they will tell you that 70 to 80% of the time is done before the algorithm, you get the algorithm state. Yeah, everybody likes to work on the algorithm side because that's more the sexy piece of data science. But The hard work goes actually in prepping the data. So we have made this prediction. What do you think is our next step now?
Compare with the value.
Excellent. So we have to compare the value with the historical data that we have. So what value did we have earlier? So this is 6329 minus 4680. 4680. So the difference is $1,640. Now, is that okay? Why is that not okay? It's not within the business requirements. And if you remember, if we look at the credit limit, US dollar credit limit, US dollar credit limit dot mean, the average credit limit is $6,200. And the difference here is $1,600. You're off by about 25%. So it's not in that range. So we need to improve it. And then there is one other problem that we have. Can somebody think of what other problem? So yes, we are not in the range and we need to improve this. So we'll work on that. But then we have another problem, which is probably a bigger problem. And that problem is that we trained on the same data and we are testing on the same data. So that is overfitting, or you are actually, you don't even have a test data. So you are training on the same data and you're testing it. It's like cheating. You already have the values. So that is not the right approach. So when you have data, when you are getting ready to actually prep the data to feed it to the model, you have to take your training, you have to take your data and you have to divide it into two different pieces. And once you divide it into two pieces, one you use for training and the other one you use for testing. So I'm going to show you how to do that, because that is a key component of how you do data science. You have to take the data, you have to divide it into training, and you have to divide it into testing piece. So from sklearn dot you see, I knew that these guys are going to be really helpful for me today. So there is a pre-built function in sklearn in this model selection class, which is called train test split. So we can feed data to the model that we can feed data to this function, and it will actually divide the data for us into different portions. And this is where we are going to convert it into training data. So we are going to call it xtrain, and then we are going to convert it into test data, which is going to be xtest. Then we will have a ytrain piece, and we will have a ytest piece. So we are going to have 4 different portions of it. And then we are going to use this train test split function, and we will provide x and y. So we will provide this x data so that the algorithm can divide into xtrain and xtest, and then we will have ytrain. The algorithm, this function will divide y into ytrain and ytest. So it will break our data set into 4 pieces, and it will do it randomly. And once we run this function, the next step usually is that I like to check that this data that I divided actually got divided properly. So we will check what is the shape of the data. And the important piece here is that X train number of rows, number of columns. So X train number of rows should match the Y train number of rows. The columns do not have to match, but the rows should match. And similarly, X test should match Y test. So now we are going to do model training again. And in this model training, again, we are going to use the same instance of this logistic regression class, LR, and we are going to do training, which we did using the fit method. And we will provide X train and Y train. Again, the concept is exactly the same. We are going to feed row by row the data so that the algorithm can train, and then we will test based on that in the next step. So when I ran this algorithm actually got trained on this X train and Y train. Now the next step after that was that we wanted to find out the error. Now, in this case, we are not going to find out the error on individual data points, because that will be too much work. So what we will do is we will look at all of the X test data and see that we have about 17,500 rows in the testing data. We are going to actually make predictions for all those 17,500 rows, and we are going to calculate an average error on all of that data. So we are going to calculate the average error. So again, scikit-learn has this function. So again, this is where the power of Python comes in handy, guys, because a lot of things is already built in. We are just calling those APIs and actually just getting the results from it. So very useful in that way. sklearn dot metrics import who's familiar with the error, mean squared error? Anybody who's familiar with mean squared error? What is mean squared error?
When you calculate all the differences, square each one.
Excellent. So mean squared error, what it does is that it actually goes to each and every row, looks at the prediction, looks at the original value, calculates the difference, and the difference could be negative or positive. So it will, to remove the negative sign, it will square the difference and then add them together and then divide it. So mean squared error will actually do all that work for you. So we don't have to. So it will do it for all 17,500 rows for us. So we are going to call this mean squared error class. Mean squared error, and we will give it the true values, which is Y test, and we will give it the predicted values, which we do not have. So before we do that, let's make predictions. So these are our predictions, and we are going to use LR and then use this method called predict to make predictions, and we are going to make predictions on all of the X test data. And all of these predictions are actually going to get stored in this variable prediction. And if you want to look at the variable, you can actually look at it here. You can say predictions. And this is credit limit for each person that you have. And then we will ask mean squared error to actually look at this value. And then look at the predicted value and the actual value, find the difference, square it, and then divide it to get the average. So we are going to say predictions. And this is our mean squared error. This number is very large because remember we squared all the values to actually get rid of the negative sign, because some error could be negative, some error could be positive. So in order for us to actually get rid of the negative sign, we squared the values. So for us to actually bring it back down to the original values, we have to take a square root of that. So one way of taking a square root is we can actually do 0.5. And the average error that we have on all of those 17,500 test data points is $3,600, $3,640 actually, which is more than 50% of the average. Oh, average. Remember, we calculated the average of the credit limit. You see, the average credit limit is $6,200, and our average error is $3,640. So it is very large. And this kind of error, your model is not really going to help the business. So what do we have to do in this case now? We have to go back to the database admin person and we say, okay, can we get some more data? So for example, in this case, we are going to assume that he gave us all the data. How can we add more data to it? Remember, I only picked 2 columns out of it. I can pick further more columns. So let's go back to the original data and let's see what other features do we have that we can use. So we used age and experience. We can actually use these features, which is current job years and current house years. I'm not going to use risk flag because risk flag is basically something which is same as derived, same as credit limit. So we are not going to use that. So we are going to pick these 2 features. We are going to go where we defined our algorithms. Oh, sorry, not defined our algorithms. We defined our independent and dependent features, and we are going to add those 2 features here. And then I am actually going to click on this cell, the cell above, and I will run everything below. So run after. And it will run. Okay. So it's saying that you didn't provide me, so we can actually comment this line out because this was just individual. We don't really care about the individual results. We will do it, all of them. And it actually did not, so we added 2 more features, years of experience, but it still did not help our algorithm at all. So at that point, we go back to our data again, and we say, okay, that's not helping out. We want something else to be added. And we are out of quantitative features now. Yeah. When we did the train test split, it is random distributed, so it doesn't sequential, or it's not sequential. It does random. So we go back and we look at other features. So there is a feature called married versus single. That might be important. This could be important that if somebody owns a house versus not owning a house. And this could also be important that if they have a car or not have a car. So these features might help us. So we go back here and we look at this. These three features, we come down here. Where do we define our independent features? And we add those features here. And then we will click in the cell above and run all after, run after. Now we get this error when we are trying to do the fit, and it's saying that I cannot convert string to float. Because remember, married and single was actually a qualitative field, and it did not have a 1 and a 0 or any numeric number in there. And the model is an algorithm, it's a mathematical equation. So it's unable to actually kind of differentiate or work on that. So what we do is we actually take that field and we convert that field into a number. Now there are many different techniques that are used to actually take a qualitative field and convert that into numbers. I am actually going to use a very simple approach, which is called one-hot encoding. Does anybody understand one-hot encoding? Oh, you understand?
Yeah.
Oh, okay. Do you want to maybe take a stab at it? What it does?
Yeah, so it takes kind of a data, so like single, married, or whatever, combines it with a 1 or a 0, and replaces it in a column on the data set.
Excellent. Excellent. So what he is saying is that you have this one field which is a single and married, and somebody was single and then the person was married. So you have different values in here. What this one-hot encoding does is it takes that one field and it converts it into two fields. And one of them is single and the other one is married. So it takes all the unique values, puts it in the columns, and then when a person is single, it puts a 1. And when a person is when a person is single, it puts a 1 here and a 0 for married. And when a person is married, it puts a 1 here and a 0. So this is one of the techniques that is used, which is called one-hot encoding. So one of the bits is hot, all others are 0. So that's why it's called one-hot encoding. And you take this feature and you convert that. So we had single and married, so there were two values. It will convert it into two features. We had another one which was house owned, which had 3 values. So it will convert it into 3 columns. So sorry guys. So this is where we actually that's where we created those or we added these new features, married, single, house, and ownership. So one of the steps that we have to do right after this is we need to convert that, or we need to use that one-hot encoding. So we are going to call this new data set called one-hot, and we will use pandas get dummies feature or method, and we will do a get dummies on this data set of independent features X. So it will take all the 3 columns that we have here, married, single, house ownership, and car ownership, and it will convert that into dummies. Are we getting close? 12 minutes. I think that should be okay. So we click here on the cell above and then run below. And smart. Yeah, I am actually going to override the X, because again, data scientists are lazy people. You could try to minimize the effort that you do, right? We let the machine do the effort. That's why we have machines. Otherwise, what's the point? Run after. We'll let the machine worry about what the value of X is. We don't have to worry about that. So we added those features and we ran everything below. And the error is still not going down. We're kind of stuck in that phase. This is where we go outside the organization. And we try to get external data. And remember what we talked about earlier, that what data is very useful in this case? Credit score. So we go to the credit union and we try to get data from that, from the credit union about the person, so that we can add that in our independent features here. We can add that credit score as a feature here in the independent features, and that credit score, because it's a driving force for what kind of credit limit should be provided, it should help that. So that is that's how you actually try to reduce the error. There is one other thing that you also look at when you are building a machine learning model. So we looked at the data earlier and we did a histogram, and we saw the data and the data distribution earlier, and we looked at a couple of data points. We looked at age and we looked at experience. But if I do a histogram here for so I am actually going to do a histogram for a couple of other features also. So what I'm trying to showcase here is, give me 1 second, this dot hist. So you see, this is what our data looks like. Now, we talked about regression, and this is what we were doing. We were using this equation. We were trying to do regression. Does anybody know that for us to run regression, there are some requirements that have to be met in your data for you to be able to run regression? Excellent. So one of the major requirements for regression is that your data has to be normally distributed. And if you do not have normally distributed data, you do need to run some transformations in order for you to actually be able to use regression. We are not doing any of those things. And our data here does not look like normal distribution. Everybody knows how normally distributed data looks like, right? The majority of the data is in the center. You have two nice tails to both of them. So this does not look like normal distribution. So when your data is not normally distributed, and there are 5 actually characteristics that you have to follow for regression. One of them, the major one, is normal distribution. When your data is not normally distributed, it doesn't. Regression is probably not the right technique for that data set. So what I'm going to show you now is that if your data is not in line with the technique that you're using, again, you are passing bad data to the algorithm. So what we are going to do is we are going to go to a different technique now. we are going to use a decision tree based algorithm to actually make predictions and see that if, because the data is not normally distributed, that if decision trees are better in terms of predicting this. And for us to run decision trees, we are going to use a algorithm called a random forest. So again, from that machine learning library, we are going to sklearn.ensemble. We are going to import random forest regressor. Again, it is going to be a regressor because we are predicting a number, but it's going to be a tree-based regressor. And we are going to call it RF. And exactly the same thing, we are going to instantiate a class of random forest regressors. And once this class is instantiated, we are going to fit. And remember, when we were doing fit, we were doing X train, comma, Y train. And we are going to let the algorithm train. So you see, this is taking a little bit longer to train because it is not a regression-based algorithm. It is a tree-based, a decision tree-based algorithm. And it uses a different technique. And the reason I picked this one is because a tree-based algorithm does not have any prerequisites. It does not require normally distributed data. It does not care about the scale of the data. It actually takes, it's a non-parametric approach. So it takes data however you have it. So we trained this new algorithm and we are going to now use the fit method. So we are going to call the predict method here. So predictions from random forest is rf.predict, and we are going to predict on X test. These are our predictions for RF. And once we have predictions from RF, we can actually use the same method, the mean squared, to calculate the error on those 17,500 rows. And instead of calling this predictions, we are going to pass the random forest predictions. And you see, we cut the error by half by using the right technique, because again, I'm not saying that regression is not a good technique, but I'm saying that our data was not, we had to do some more prep for the data so that we convert that data or we transform that data into normally distributed data. And when the data is normally distributed, we can then use a regression technique. But in this case, because the data was not normally distributed, we were kind of stuck in that very big error range. And using the right technique, using a tree-based technique, we were able to cut it down. Again, this is not the end point. And because you all came for a tutorial, you came for a class or a session, you were expecting homework, right? So your homework is that you have to bring it down a little bit further. Bring it down to closer, less than $1,000. Less than $1,000 would probably be okay. But by adding more data to it, and when I say adding more data, the data that we have, if you add more data from there, if you bring in more data points from there, you will be able to bring. If you bring in profession, if you bring in other elements that are there, you'll be able to bring it down. But try that. If you have any questions, if you want to reach out to us, you can reach out to. So there is a on the DataCon LA page. There is a link to my LinkedIn. You can go to my LinkedIn, or you can go to LearningFuze's LinkedIn, and there you know how to get a hold of me. You are most welcome to actually reach out, and if you get stuck, I'll be happy to help out. Any questions? Again, I would like to thank Learningfuse for hosting this session and allowing me to come and talk to you guys. If you guys have no other questions, thank you very much for attending. Hopefully this was useful, and I will pass it back to Bell to wrap this up.
thank you, Zia, for the presentation today, and the attendees too for the first question and interaction during this session. You can contact the speaker, you know, you have any further questions you want to ask, just, you know, asking the basic issue. And thank you again, everyone, for joining today's session. So have a good weekend. Thank you.
Thank you, guys.
Yes.
You guys ever ran like a decomposable time series model and got negative predictions?
Oh,
Yeah.
negative prediction.
Yeah, I run for Facebook profit,
Okay.
like website engagement, just trying to predict, web traffic.